let's write a program. Okay? We're going to write a program to illustrate why we need this next class of instructions. Here's our memory map. Okay? Here's our memory map. And I come along, I'm going to start an instruction. You know what I'm going to do? I'm going to go out and read from an input port, and then I'm going to write it to an output port. Okay? And I said read and write. That was stupid. I should have said loaded from an input port and stored to an output port. So my code might look like this in assembly language, which means using mnemonics. I might say to myself, here's my inputs, F0. I might say load a direct with F0. I have just gone down to this input port and grabbed 8 bits, and I put it in A. Now I got it, and what's on that port? I don't know, it could be switches, okay? It could be buttons, it could be a connector where information is coming from the outside world. But for a computer, we don't care, it's just an address. We know information is coming in. What if I then did store A to an output port? Well, I could store that to E0, so I could say store a direct to E0, okay? And then I could also store that somewhere else. Imagine where you might read from like the dip switches on the FPGA, bring it into A. But you wanted to display it on, let's say, the red LEDs. The red LEDs are going to be on an output port. But then what if you wanted to display it to one of the character displays? That's going to be another port. And then another display is going to be another port. Okay? So you have this situation where we might store this thing to E0, which is going to be one port. I still have that same information in my register, so I could say store a direct to E1. Okay? All right, we just wrote somewhat of a program, and now I'm kind of interested in the following. I want to know what this would look like if it was in memory. All right, ones and zeros here. All right, so here I go. I'm going to go over to memory. Where do you want to put this program? I want to put it at 0, 0 because that's where I'm going to start executing code. So I come over to you and I say, I'm going to have my address right here, and I'm going to have my data, and this is program memory. And I'm going to have it 0, 0 and 0, 1, the first instruction. I got to go look up what the opcode is for LDA. Now, we are building an instruction set. We've built up 4 instructions, and we're also assigning the codes so that we can actually implement this. In fact, I decided it would be kind of neat to give you a big table of all the opcodes and all the mnemonics that we're going to use. So you'll notice that in the book, I give you this thing that says, here's all the instructions that our computer can execute, and I also give you a shortcut of what not only the mnemonic, but also the opcode. So when I come out here and I look at this table, okay, I would then say LDA direct is actually 87. That's the opcode. So if I looked into my memory system, I would say, okay, I'm going to have 87 followed by F0. That is the instruction. That's what I would need to put in my program memory as a constant in order to get that instruction executed. Then I'm going to have 02 and 03, which are going to be a store a direct. That's a 96 opcode followed by the operand, which is E0. And then I'm going to do 04, 05, and that's going to be another 96er followed by an E1. I say execute. You start this process of fetch, decode, execute. You go out. The program counter's pointing at 87. You grab that opcode. You put it in the instruction register and you decode it, increment the program counter. You grab F0. It is what? An operand, but it's a address. Okay? Where should I stick the operand? Memory address register. I increment the program counter. I grab 96. It's an opcode. Okay? Actually, before I do that, I go out to F0 and I read from it. And I put that information into what? A. Now I go to my next instruction, 96. I go fetch the opcode. Where do I put it? Instruction register. I then increment the program counter. I go get the operand, which is what? E0. It's an address. Where do I put it? It's an address, so I always put it in memory address register. Whatever was in A, out to that address. Bada bing. It shows up on the LEDs. Oh, now I go to this dude, 96. I read it again, read the opcode again, put it in the instruction register, decode it, increment the program counter, go grab the operand, which is an address. Where do I put that? Memory address register. And then while I'm sitting there, I go ahead and write to that address, increment the program counter, and then what do? Crash. The computer now crashes. Why did it crash? Because I was so happy that I forgot that there's nothing that resides at this address right here, and my program counter is now pointing there. It goes and reads that address, puts it in the instruction register. My CPU control state machine doesn't know what to do, so it just crashes. Blue screen. Okay? So, what could we do here? Well, you know what would be awesome? What if we could put this program in a loop? Okay? Because if you think about reading from switches, okay, wouldn't it be cool if we could read from the switches, which are on, let's say, F0, and then let's write it to the red LEDs and then write it to a character display. Okay? So we read from it, let's say load from that address, store, store, repeat. Load, store, store. These graphics don't make any sense. Let's do it like this. Load, store, store. Is that better for you? Okay? Load, store, store. Load, store, store. Now, how do we get our program to, instead of executing code here, go back up to here? Well, you know how we do it? It's with an instruction. Okay? It doesn't magically do it. We have to tell it, go back to the beginning and start executing code. That is accomplished with the third class of instruction, which is called the branch. Okay? It is an instruction, and what it does is it changes the program counter. Okay? The program counter is what's tracking where you are in your program memory as you execute code. Sometimes, almost most of the time, it's incrementing by 1. It's just going bada bing, bada bing, bada bing, bada bing, bada bing, bada bing, bada bing. But then every once in a while, we need to branch to a different location that isn't just +1. Does that make sense? Okay. So, we are going to have a whole bunch of branches. These branches right here are going to alter the program counter. The first branch that you absolutely need is called a branch always. Okay? That is an instruction that will do nothing else but say, here's a value, put this value in the program counter, please. Once it's in the program counter, you know what happens? The CPU will then go execute the next instruction at that value. It will go to that value, that address that's in program counter, grab the next opcode. So that's the way that we get this program to go to other regions of program memory and execute another instruction. Okay? So we have our first looping construct. So we're going to have branches. All right, now, technically speaking, you guys want to get technical just for a second, just for a little bit. We're going to have unconditional, and we're going to have conditional. No song that's with conditional. Okay, unconditional means just do it. There's really nothing to talk about. Conditional means, let's talk about it. Okay? Sometimes I want to branch with a conditional branch. Sometimes I don't want to branch. Okay? That's a conversation for a different day, though. Okay? I want an unconditional branch that just branches all the time. Okay? We just want to put this baby in a loop and go have lunch. All right. So let us look at, one more time, our little cartoon program execution of a branch always. Okay? So I walk up to you and I say el following. We are going to look at this instruction. Okay? Luckily, the addresses match our program that we just wrote. Isn't that cool? Almost like we planned it. Huh? So we are going to put an instruction that is at memory location 06. And the reason is that That's what we're doing here. We want to have an instruction that sits right here, which will put the program counter back to 0, 0. We are going to use a mnemonic called BRA. You know what it stands for? It's branch always. We are looking at a branch always. I tell you that I want to branch always to 0, 0. This is an address, correct? It is an address. It isn't going in the memory address register. It's going in the program counter, okay? We are going to assign a mnemonic of 20. The instruction will be looking like as follows. Opcode 20 followed by an operand of 0, 0. Let us assume for 1 minute that we are sitting with the program counter right here because we have just executed this program that we wrote. The program counter is pointing at 0, 6, and I want to execute this instruction. Step 1, fetch. I take the program counter, and I need to go read from that address, so I put it, program counter is pointing at 0, 6, I put it in the memory address register. I take it back and put it right there. The memory address register now has, this is the address, and it has 0, 6 on it. If you can see that. Can you see that? It's got 0, 6 on it. That does not look like 0, 6 at all. But you're going to believe me, right? 0, 6. Looks like a G. Don't worry, it's a 6. So I go 0, 6, and I go read. 20 comes back to the CPU. Where should I put all 20? It's an opcode. It's going into the instruction register. Instruction register. So instruction register has 20. You know what I do now? I increment the program counter because I haven't decoded this instruction yet. The program counter is now incremented to 0, 7. So now it's 0, 7. You're right. Thank you for paying attention. 0, 7 is now the program counter. I decode it. I say 20. That's a good instruction. I know what that is. I know the following. It is a branch always. I know that it has an operand, and I know that operand is the address to put into the program counter. So I do the following. I put 0, 7 onto the memory address register. That means I am now going to read from 0, 7. I go out to 0, 7, and I grab 0, 0. So now here comes 0, 0 into the CPU. And usually, at this point, we would have incremented the program counter. In this situation, we don't need to, do we? Because we're going to override it. Here comes 0, 7. Or excuse me, here comes the information at address 7, and it's 0, 0. Here it comes. I usually either put this into the memory address register or the instruction register, but this time where am I going? Bada bing, bada boom, into the program counter. The program counter now has a value of 0, 0, and I am done with the instruction. At this moment in time, based on what we've talked about before, what is the next thing that the computer will do? We go back to the top of our finite state machine and we say fetch. Fetch where? 0, 0, because that's what's in the program counter. And I have now gotten into a situation where if I have my program over here, 2000, I will sit here and I will loop. I will loop. I will loop. I will loop. And as you sit there with your computer and you change those switches, you will load from it and you will store, store. Load, store, store. Load, store, store. How's that feel? We now have the ability to build a computer. Yes, yes. Isn't this fun?